Good day, students. Learning gets better one step at a time, and today we're taking another step forward. Let's see what's ahead. In our last lesson, we learned about subtraction of numbers less than 1 in logarithm. In today's lesson, we will focus on multiplication of numbers less than 1 using logarithms. Follow me as we learn together. Note down the following. The basic rules of multiplying numbers less than 1 using logarithms is the same as with numbers greater than 1. These also involve the laws of indices. Let's look at an example to see how this works. Example 1. Evaluate 0.7248 multiplied by 0.03405 using logarithm tables. Solution. Step 1. We will draw a table and insert the numbers we are evaluating in the first column. Then, we will first get the characteristic of 0.7248 before we solve for the mantissa. Recall that, in lesson 2, to get the characteristic of the logarithm, we counted the number of zeros after the decimal point and before the first non-zero digit, and converted the value into a negative number. In the number 0.7248, we get to 7 right after the decimal point. So, we will count only one place. That means the characteristic of 0.7248 is bar 1. Let's now solve for the mantissa. Remember the process of looking for the mantissa of a number in the log table. You can refer back to lesson 1 for the steps if needed. To get the mantissa, we will read from tables. Log 72 under column 4. Then we will add the mean difference of 8 in the row, which is 5. This gives us 8597 plus 5. Our answer is 8602. We will do the same thing for the second number. To get the characteristic of 0.03405, we will count the number of zeros after the decimal point and before the first non-zero digit and convert into a negative number. So let's count. 1, 2. We will stop here, because 3 is the first non-zero digit after the decimal point. So, the characteristic is bar 2. To get the mantissa, we will read from tables. Log 34 under column 0. We will also add the mean difference of 5 in the same row, which is 6. This gives us 5315 plus 6. Our answer is 5321. Let's proceed with our solution. Remember that, for multiplication using logarithms, we add the logarithmic values of the numbers. Let us now add up the two results. Applying knowledge of addition and subtraction of numbers in logarithm from the previous lesson. 2 plus 1 is equal to 3. 0 plus 2 is equal to 2. 6 plus 3 is equal to 9. 8 plus 5 is equal to 13. We write 3 and carry 1 over. Let's calculate the characteristic separately. 1 plus bar 1 plus bar 2 equal to 1 plus open bracket minus 1 close bracket plus open bracket minus 2 close bracket. Let's apply the Bodmer's rule. To open the brackets, we will multiply the plus signs before each bracket by the minus signs inside it. Recall the rule for multiplying and dividing signs also stated in the previous lesson. So let's write equal to. First, we will bring down 1. Plus times minus 1 is minus 1. Plus times minus 2 is minus 2. Let's solve. 1 minus 1 is 0. 0 minus 2 equal to minus 2. This means that the characteristic is bar 2. Therefore, the answer for the first step is bar 2.3923. Let's now go to the next step. For the second step, we will get our antilog table. Let us draw another table and insert the answer from step 1. We will now read from tables, antilog of 39 under column 2, and add the mean difference of 3 in the row, which is 2. This gives us 2466 plus 2. Our answer is 2468. The characteristic of the result in step 1, bar 2, shows the index value of 10, which multiplies the antilog to give the answer. That is 2.468 times 10 raised to power minus 2 equal to 0.02468. Therefore, 0.7248 multiplied by 0.03405 equal to 0.02468. Assignment. Write down the following assignment and try solving them yourself. Evaluate the following using logarithm tables. Take your time, stay focused, and do your best. In conclusion, we have learned how to multiply numbers less than 1 using logarithms. In our next lesson, we will learn about division of numbers less than 1 using logarithms. You are doing great. Keep pushing forward. Thanks, and goodbye.